Hello dear students, we are back again. Today's lesson, we're going to explain angular speed in chapter 1, section 1 for grade 12 students. But before explaining the angular speed, I would like to remind you the rotational motion. What is rotational motion? Is any object that rotating or spins around an axis. Okay, so unlike the linear motion, in linear motion, the object is moving on a straight path. Okay, so let's draw a x and y plane, the coordinate x and y. Okay, x and y, and for example, when an object is rotating or moving in a circular path, okay, so this object has arc length, okay, so the distance, okay, this distance is the radius from the center and from the axis of rotation to the object that moving in a circular path or rotating object, and this is the angular displacement of this object. Okay, and this curve is arc length. Okay, so you can finding the angular displacement by dividing the arc length to the radius. Okay, and to the radius. So when this object is rotating or moving in a circular path, this object has angular speed. Okay, and maybe has angular acceleration. Okay, so this is the rotating of an object around an axis. So this is the axis of rotating, okay, or axis of rotation. So let's write the variables for linear motion and the variables for the rotational motion. So the equations, they have the same equations. There is no difference between the equations of linear motion and rotational motion, but the difference is in the variable. Some variable that can be used to calculate in rotational motion is completely different with the linear motion. Okay, so this is linear quantities or linear motion and rotational motion. This is linear motion and this is rotational motion. Okay, so in linear motion we have what? We have displacement. Okay, but in rotational motion, instead of displacement, we have what? We have angular displacement. In linear motion that you have learned in grade 11, x is represented for the displacement and measured in meter. But theta in rotational motion, so you will study in grade 12, is the angular displacement of an object. Okay, so and measured in what? In rad. In the case when the angular displacement is given in degree or revolution, then you have to convert it to rad. Why? Because the question can be solved for the angular speed with the rad, not with the degree or rev. Okay. Another variable is velocity. Velocity in linear motion, as you learn it, is equal to what? Delta x over delta t. The rate of the displacement per unit of time. Okay, so but in rotational motion, instead of velocity, we have what? We have angular velocity. We have what? Angular velocity, which is equal to what? Delta x becomes delta theta, and time is the same. Okay, another variable in linear motion is acceleration, which is equal to change in velocity, the time rate of change of velocity. Okay, so but in rotational motion, instead of acceleration, we have angular acceleration. Be careful, please. Instead of acceleration, what we have in rotational motion? We have angular acceleration, which is the time rate of changing of angular speed, delta omega per unit of time. Okay, so in linear motion we have momentum, which is equal to mass times velocity. But in rotational motion we have what? We have angular momentum, which is equal to I times omega, sorry, I times omega. I is the moment of inertia and omega is the angular speed. So we will study in detail in chapter 2. And also in grade 11, you have learned about the work, and work is equal to what? Is equal to Fd, okay, or Fd cosine theta. But in rotational motion, we have torque is equal to Fd sine theta in the given, when the angle is given. Okay, so this is some variables from linear motion and rotational motion. So for the kinematic equations, like the four kinematic equation in linear motion exactly can be used for the rotational motion, but with different variables. Okay, so the four kinematic equations for kinematic equations, for linear motion and rotational motion. Okay, so as you learned in grade 11, we have four kinematic equations, like for example, V final is equal to V initial plus A delta T. Okay, so this equation can be used only when acceleration is constant, or at uniform acceleration, the four kinematic equation can be used. When does the four kinematic equation can be used to solving the question? When acceleration is constant for linear motion, or when the angular acceleration is constant for rotational motion. Be careful, okay? But for rotational motion, instead of V final, we have omega final is equal to omega initial plus, instead of acceleration, you have to write down the angular acceleration t. Okay? The second equation is delta x is equal to, the second equation, delta x is equal to v initial delta t plus 1 over 2 a t squared. This is for linear motion. But for rotational motion, instead of delta x, you have to write delta theta is equal to what? Angular speed initial t plus 1 over 2 angular acceleration and t squared. Okay? So another equation in for kinematic equation is V final square is equal to V initial square. It's not very clear. I'm going to write in another color. Okay. V final square is equal to V initial square plus A T square. But in rotational motion, instead of V final and V initial, you have to write down omega final square, omega initial square plus, sorry, there is 2 here, 2A alpha angular acceleration T square. The last equation of the for kinematic equation is delta x displacement is equal to 1 over 2 V initial plus V final times delta t. This is for linear motion, but for rotational motion, instead of delta x, you have to write down delta theta, 1 over 2, instead of V initial and V final, you have to write down omega initial, omega final times delta t. Okay, so as I told you, the four kinematic equations can be used in both types of motion, linear motion and rotational motion. So when does the four kinematic equation can be used for solving question? In the case when acceleration is constant. When what? Acceleration is constant. But for rotational motion, when angular acceleration is constant. is constant. Okay, so the angular speed is measured in rad per second, and angular acceleration is measured in rad per second square. So time is measured in second, and radius with the arc length is measured in meter. So for the students, you can recognize all the physical quantity only by the units. So that is why it is very important to know the units for every variable in physics. Okay. Let's talk about the angular speed. Okay, as I mentioned before, what is the definition of angular speed? So it has been brought in the Wizari exam many times. So that is why you have to be very careful to know and recognize the definitions. What is the definition of angular speed or average angular speed? Is the rate. What do you mean by rate? It means that the fraction. Is the rate. When we say is the rate, it means that something divided by time. Which body rotates about an axis, or the time rate of what? Change of angular speed. Change of what? Angular speed. Okay, angular displacement, sorry. Angular displacement. What is the definition of angular speed? Is the time rate of angular displacement. Measure it in what? Measure it in, what is the unit of the displacement? Angular displacement? Rad times second. So that is why angular speed is measured in rad per second. Okay? So average angular speed in rad per second, and theta is angular displacement in rad, and t is time interval measured in second. In the case when the angular speed is given in rev per second, or degree per minute, or rev per minute, then you have to convert to rad per second. Okay? So the units of angular speed, it is SI unit is rad per second, but sometimes it is given in rev per second or rev per minute. In the case when angular speed is given in rev per second or rev per minute, then you have to convert to rad per second. How can you convert rev per second? Rev per second, you have to multiply by 2 pi. Okay. For example, when angular speed is given 2 rev per second, how can you convert to rad per second? You have to multiply this 2 by 2 pi. Okay. And in the case when rev per minute is given, when the angular speed is given in rev per minute, you have to multiply the number that given in the question by what? 2 pi over 16. Why 2 pi over 16? Because convert rev to rad, you have to multiply by 2 pi. Convert minute to second, you have to multiply by 60. That is why if the angular speed is given in rev per minute, you have to multiply the given value by what? 2 pi over 60. But in this case, rev per second, you have to multiply by 2 pi only without changing the time, because the time was already given in second. In the case when angular speed is given in rev per hour, be careful. How can you convert to rad per second? Convert rev to rad, multiply by 2 pi. Convert hour to second, multiply by 3,600. So in this way, you can convert the rev per hour, rev per minute, and rev per second. Okay? So as you know, the angular speed can be positive and negative. When does the angular speed becomes positive and when does it becomes negative? In the case of counterclockwise, the angular speed, angular displacement becomes positive. But in the case of rotating or moving clockwise direction, the angular speed and angular displacement becomes negative. Question 2 in chapter review, look at this question. Distinguish between what? The linear speed and angular speed. So for the student, it is very important to make a distinction between what? Distinction between what? Between linear quantities or rotational quantity, or linear motion or rotational motion. What is the difference or distinguish between linear speed and angular speed? For the linear speed, this is the distance traveled in a given time interval measured in meter per second. As you learn it, V is equal to what? The time rate of the displacement, or displacement over time. This is linear speed. Measured in what? Meter per second. The angular speed, what is angular speed? The angular displacement traveled in a given time interval. Angular speed is the angular displacement traveled in a given time interval and measured in what? In rad per second. But linear speed, the velocity in linear speed measured in meter per second. Okay? So we have some important notes here. Please be careful. The first note, sometimes angular speed will be given in rad per minute, rad per hour, rev per minute, or rev per hour. However, you have to, or it should be converted to rad per second, as I mentioned before, okay? So the angular speed is a vector quantity. What do we mean by vector quantity? In physics, when we say something is a vector quantity, it means that this variable or this quantity has both magnitude and direction, okay? Like force. Force is a vector quantity. Why? Because the force has magnitude and direction. Okay. To convert rev per second, rad per second, we studied multiplied by 2 pi, rev per minute to rad per second multiplied by 2 pi over 16. Okay. The angular speed, because it is vector quantity, that is why it could be positive and negative. Angular speed is a vector quantity that has both magnitude and direction. Okay, or direction. And its direction is the same as the angular displacement. When does angular displacement becomes positive and when does angular displacement becomes negative? In the case when the object rotates or moving in counterclockwise, the angular speed becomes positive. But in the case when the object is rotate or moving in the clockwise direction, the angular speed becomes negative. Okay, so if it's hard to understanding this or this positive and negative sign, sometimes the students they forget when does omega is positive and negative. If you have a hard time here, you can recognize yourself like that. Okay, let's draw the plane of x and y. Okay, as you know, this is the first quarter, this is second quarter, this is third quarter, and this is fourth quarter. Okay, when the object is start rotating here, okay, when the object is rotating like that, okay, what happened to the number of quarter? In this rotating is clockwise or counterclockwise? It is counterclockwise. Okay, this rotation is what? Is counterclockwise. How can you recognize omega has positive sign in the case of counterclockwise? So you can recognize like that. When the object is moving counterclockwise, what happened to the number of quarter? Increases from 1 to 2 to 3 to 4. The increasing of number of quarter, it means that positive. Okay, the positive sign, it means that increasing things. Okay. But in the case when the object is moving counterclockwise here, counterclockwise from here, for example, okay, what happened to the number of quarter? From 4 to 3 to 2 to 1. Okay, so that is why when the object is rotating clockwise direction, the value of angular speed and angular displacement becomes negative. Okay, so for the people, you need to make an important distinction between the clockwise direction and the counterclockwise or anti-clockwise direction of the angular speed. Okay, and the following rule, this rule can be used if two angular displacements and two times are given in the question. So as you know that for the rigid object, like rigid body, okay, every point on the rigid object, like point A, point B, okay, they're rotating on this plane or on this object. So which one has more angular speed? They have the same angular speed. They have the same what? They have the same angular speed. So that is why in the case when two angular displacement or two times are given in the question, you can use this relation. Okay, omega 1, omega 2. Omega 1 is equal to theta 1 over T1, theta 2 over T2. Okay? So the angular speed of the following quantities are constant. Okay? We have some constant angular speed in our daily life. Okay? For example, the rotational motion of the second hand of clock. You know that the second hand of the clock will rotate with the clockwise direction. Okay? So, to find the angular speed of the second hand of clock, as you know, so at first you have to write down the equation of angular speed for what? Second hand is equal to what? Delta theta divided by t. Okay? By getting one complete cycle, what is the value of angular displacement for one complete cycle? For the second hand, we have 2 pi rad. One complete cycle for the second hand has 360 degree, 1 revolution, and 2 pi rad. For one complete cycle, time for the second hand is 60 seconds. So, you will not require to write the direction of the angular speed of the second hand, because the direction of the angular speed is based on the clockwise and counterclockwise. So that is why when you say the second hand is rotating, so you will not require to write down the sign of the angular speed. Why? Because the second hand is already has a clockwise direction, okay, of direction. And if you multiply this number, 2 pi divided by 60 is equal to 0.104 rad per second. Okay? The second one, so also you can finding the angular speed for the second hand for 2 revolutions, for 3 revolutions, for the many revolutions, but there is the same thing. Okay, there is no difference between the angular speed for 1 complete cycle or for 2 complete cycle. Why? Because in the case for 2 complete cycle, how many rads do we have? 2 times 2 pi. For 2 complete cycle, how many seconds do we have? 2 times 60. These 2 cancel with 2. That is why it's the same thing. So the angular speed of the second hand of the clock is constant. It is magnitude you can find like that. Okay? The second one, the rotational motion of a minute hand. As you know, the clock has 3 hands. Minute hand, second hand, and hour hands. Okay? Hour hand. For the minute hand, the second one, how can you determine the angular speed for the minute hand? Delta theta over delta t. Okay? So, for the minute hand, by getting 1 complete cycle, how many rads do we have for 1 complete cycle? 2 pi rads. For 1 complete cycle for everything, for minute hand, second hand, the revolution of Earth around itself, the orbiting Earth around the sun, every complete cycle, every 1 full cycle has 2 pi rad. Okay? Divided by time. How long does it take? How long does it take for the minute hand to complete 1 full cycle minute hand? It takes 60 minutes. How long does it take? It takes 60 minutes. Is it possible to solving the question with the minutes? No. So why? That is why you have to convert to what? To second. How can you convert 60 minutes to second? By multiply 60. 60 minute times 60 is equal to 3,600. 3,600. So is equal to, look, to convert, this is minute to second, you have to multiply by 60, and this 2 will cancel with the 3,600. It's going to be pi over 180. So you are not required to write the sign. Okay? Is equal to 0.0017 rad per second. So what is this? This is the value of angular speed for minute hand. If they bring in the auxiliary exam, calculate the angular speed for the minute hand, or which of the following is the angular speed for the minute hand without giving any value. So the student should be know, and you have to know the angular speed of the minute hand is constant and is equal to theta divided by time. The theta for one complete cycle is 2 pi. So the time for one complete revolution or cycle for the minute hand is 3,600 seconds. Okay? The third one, the rotational motion of our hand. The rotational motion of our hand is also constant. Okay? At first, write down the equations of the angular speed for what? For our hand divided by time. 2 pi. Okay? 2 pi divided by, for 1 hour, how many minutes do we have? How long does it take for the minute hand, for our hand, from 12 o'clock to 12 o'clock? How long does it take? 1 hour. So 1 hour is equal to how many minutes? Is equal to 60 minutes. So 60 minutes is equal to how many seconds? Is equal, now you have to convert to 60 minutes, and time is for 260 to convert into the second. So for one complete cycle for our hand, it takes 12 hours. Sorry, I do apologize. The hour hand for the clock, how many hours covered by the hour hand for one full cycle? 12 hours. Sorry, not 1 hour. 12 hours. How long does it take the hour hand for one full cycle? 12 hours. 12 hours is equal to how many minutes multiplied by 60? How many seconds multiplied by 62 seconds? Okay, 12 times 60 times 60, and the result is 1.45 times 10 power negative 4 watt per second. Okay, this is about the second hand, minute hand, and hour hand. Okay, so it has been brought in the Wizari exam. Be careful, please, dear students. Okay, so it may bring also in the Wizari exam. For the Earth, rotation of the Earth around itself. What do you mean by rotating Earth around itself? It means that to occurring day and night. Every 24 hours, the Earth covers one full rotation around itself. How long does it take for one complete rotation of Earth around itself? Be careful. Around what? Around itself. It takes 1 day. It takes 24 hours. Okay? And so how can you find the value of this angular speed when the Earth rotating around itself? Look, this is the rotating Earth around itself. Okay? At first, you have to write down the equation for Earth around itself. Be careful. Not everything orbiting around the sun. Theta divided by time. Okay? How long does it take? As I told you, 1 day, 24 hours it takes for one complete revolution of Earth around itself. Okay, so one complete revolution around itself is equal to how many rads? Is equal to 2 pi rad divided by how long does it take? 1 day. 1 day. Convert to hours. How many hours do we have per day? 24 hours. We have what? 24 hours, please. Time is convert hour to minute, multiply by 60. Then multiply by 60 to convert to what? To second. Okay? Now, how can you convert day to second? You have to multiply each day. We have 24 hours, multiply by 24 hours. And 24 hours convert to minute, multiply by 60, and convert to second, you have to also multiply by 60. Okay, so the angular speed of Earth around itself, be careful, is equal to what? its value is constant, and 7.25 times 10 to the power negative 5 rad per second. It is too less. That is why we cannot feel this rotating of Earth around the Sun. The orbiting Earth, another angular speed for what? For Earth also. But what is the difference between these two angular speeds? We have Earth here and also we have Earth here. For this one, the Earth rotating around itself. Rotating Earth around itself takes 24 hours. But when we say the orbiting Earth around the Sun, look, orbiting Earth around the Sun, how long does it take? How long does it take for the orbiting Earth around the Sun? It takes 365.25 days. It takes 1 year. One complete revolution of orbiting Earth around the Sun is 1 year. For 1 year, how many days do we have? 365.25 days. Okay? So how can you calculate the angular speed of Earth around the Sun? Not around itself. Around what? The Sun. Is equal to theta divided by time. Because the Earth is rotating counterclockwise. Sorry, I forgot here. Earth rotating around itself in counterclockwise. So that is why it should be positive. Why the rotating Earth around itself is positive? Because the Earth rotating around itself in counterclockwise direction. Okay? And also for the orbiting the Sun, how the Sun is orbiting how the Earth is orbiting the Sun, in which direction? In counterclockwise direction. That is why the angular displacement considered as a positive. Okay, so 2 pi for one complete orbiting of Earth around the Sun divided by time. The time is different from rotating Earth around itself. For orbiting Earth around the Sun, we have 1 year. Time is 365.25 days. Time is convert day to hour, 24. This is 24 hour. 24 hour convert to minute, multiply by 60. Minute, 2 second, multiply by 60 to convert to second. So by calculator, you can get that the value of angular speed of Earth around the Sun, Earth orbiting around the Sun, is equal to 1.99. 1.99. Time is 10 to the power negative 7 rad per second. So this question has been brought in the Wizari exam many times. Be careful. This question is very important, and it has been brought in the Wizari exam. The last one, the orbiting moon around the Earth. So sometimes the moon, it takes 28, 29 days, 30 days. So that is why we can assume that for one complete cycle of the orbiting moon around the Sun, it takes 30 days, and its value is equal to 2.42 times 10 power negative 6 rad per second. Okay, so that's all about the angular speed for some sometimes the angular speed is constant for something like minute hand, second hand, and orbiting the Earth around the Sun or something like that. Okay, so for these variables, all of them, they have zero angular acceleration. All of them, they have what? Zero angular acceleration. Why? Because the angular speed is constant. Okay, so when does the angular acceleration will occur or will exist in the object? When the object's angular speed changes. As you learned in grade 11, what is acceleration? Is the time rate of changing displacement. Is the time rate of the changing speed. When the speed is remain constant, it is acceleration 0. When does acceleration of an object is 0? In two conditions. When the object at rest has 0 acceleration, 0 speed, or when object is moving with constant speed, its acceleration is 0. Okay, so let's solve the sample problem and the practice of angular speed. Raskar spins on a stool in counterclockwise. In what? Counterclockwise. When you see the counterclockwise, it means that omega is positive, theta is positive. Okay? And counterclockwise direction with an average angular speed. Average what? Angular speed. What is this? This is omega. How did you know this is omega? Because it's mentioned in the question and also by the units. Okay? By the units, the students can recognize all physical quantity. Okay? Look, rad per second is the unit for angular speed. Angular speed is 4 rad per second. In what time interval? What is unknown? T. The time interval is unknown. Will Raskar's feet have an angular displacement of 8 pi rad? What is this? Angular displacement. The angular displacement was given 8 pi rad. Okay, but don't forget, please, the angular speed is positive or negative? It should be positive. Why? Because it is rotating in counterclockwise direction. Okay, why the theta and angular speed is positive? Because the object is rotating in counterclockwise direction. Okay, so how can you calculate time interval? It's too easy. Just plug in. Okay, at first write down the equation of angular speed. Theta divided by time. Theta was given 8 pi divided by 4. Angular speed is equal to 2 pi rad per second. So you can analyze 2 times 3.14, 6.28 rad per second. Okay? Practice 1B. Practice 1B. A car tire rotates with an average angular speed. What is this? This is angular speed. Was given in rad per second. Its magnitude is 29 rad per second. In what time interval will the tire rotate 3.5 times? Rotate 3.5 times. What do you mean by rotate 3.5 times? It means that when the object is start here, this is 1 revolution, 1 time, 2 time, 3 time, and half. How many revolutions do we have? We have 3.5 revolutions. So it means that the theta was given in revolution in this question. Please pay attention. How the angular displacement was given in this question? In what? In degree or rad or rev? In rev. How did you know? Because it was mentioned in the question. The object will, the tire rotate 3.5 times. 1, 2, 3.5 times rotating. It means that revolution. How many revolutions do we have? 3.5 revolution. Is it possible to finding the time or angular speed with revolution? No. Why? Because the angular speed was given in rad per second. So that is why we have to convert this rev to rad. How can you convert rev to rad? So we studied and you have learned it. Okay. If you see the previous video in chapter 1, so you can find out that how can you convert between the scales of the angular speed. In this case, we have to convert rev to rad. So then we have to find theta in rad. You have to make a fraction, as I told you, as I explained it for you. You have to write down the value of the rad for 1 complete cycle, 2 pi, divided by what? By 1 revolution. Time is, the theta was given 3.5. 2 pi times 3.5 rev, theta in rad is equal to 7 pi rad. Or you can multiply by is equal to 7 times 3.14 rad. Okay? So after converting the revolution to rad, now you can find the angular speed which is equal to the angular displacement divided by time. So rearrange the equation to find time. T is equal to what? Is equal to theta divided by the angular speed. So the theta was given in rev, but we converted to rad by multiply by 2 pi was equal to 7 pi rad divided by 20. So the time is equal to what? 0.76 second. It is too easy, okay? Okay. So because the question did not mention about the direction of the rotating object, so that is why you have to consider as a positive sign here, okay? So fill in the unknown quantities in the following tables. Already I solved all the branches, so please pay attention for these questions. It is very important because it has been brought many times in the Wizari exam, okay? For the first one, branch A, what is given? The theta was given and time. Just replace theta divided by t. For branch B, what is given? The angular speed, average angular speed is given. Time also is given. Theta is unknown. To find theta, you have to multiply angular speed by time is equal to 0.0375 rad. Look at branch C and be careful, please. What is unknown? What is hidden here? The hidden here is angular speed. The average angular speed is unknown. Okay? So what is this negative 1.2 rev? This is angular displacement. The angular displacement is given in what? In negative 1.2 rev. What does the negative sign indicate in this value, in the angular displacement? The negative sign indicates that this object rotates clockwise or counterclockwise. The object rotates clockwise direction, as I mentioned before, okay? So that is why the value of angular speed, it should be negative. So what is the time? The time is given 1.2 seconds. How can you calculate angular speed is equal to theta divided by time? But the theta, we have a problem with the angular displacement here. What is the problem here? The problem is the angular speed, the angular displacement is given in rev. You have to convert to rad. How can you convert rev to rad? Multiply by 2 pi is equal to negative 2 times 1.2. 2 pi times the 1.2 divided by 1.2 second, and angular speed was given in negative is equal to negative 2 pi rad per second. Okay, and the last one, the time is unknown. Just replace to find out the time. Okay. Question 6 from chapter review, and also this question is very important, and it has been brought in the Wizari exam. Okay, this is Wizari exam. Be careful. How long does it take the second hand? How long does it take for what? Second hand. Delta T is unknown. For what? For second hand of clock. To move through 4 rad. What is this 4 rad? This is angular displacement. Is given is equal to 4 rad. Okay. How can you find the time without angular speed? This is impossible, because we have 2 hidden here. The angular speed is equal to theta divided by time. To find time, we need what? The angular displacement and angular speed. Do we have angular displacement? Yes, was given in rad. Do we have omega? No. We don't have omega or angular speed in this question. But as I explained it a few minutes ago, about the angular speed for the second hand is constant. Is what? It is omega is constant. How can you find this value of the omega? Omega is equal to what? Is equal to theta divided by t, 2 pi divided by 60. So you can replace. Theta was given 4. Angular speed is equal to 2 pi divided by 60. rearrange, and is equal to 38.2 seconds. So it means that how long does it take for the second hand move through the full rod? It takes 38.2 seconds. Question 27 also is a very good question and is a Wizari question. That is why you have to pay attention, please. Look at this question. Find the average angular speed. Find what? Average angular speed. Omega of what? Of Earth. Oh, it's easy. But Earth, or rotating around itself or orbiting around the sun. It should be mentioned in the question. About the sun. Oh, about what? The sun. It means that this is Earth, this is sun. What is the axis of the rotation for the Earth or orbiting around the sun? The sun is the axis of rotation, okay? And the Earth is orbiting around the sun and it takes 1 year, okay? So the hint is given here. The Earth orbits the sun once every 365.25 days. Okay, so you can write down the equation of the average angular speed is equal to what? Theta divided by time. For one complete cycle, how many rods do we have? 22 pi. This 2 pi is positive or negative? This is positive. Why? Because the Earth orbiting around the sun in counterclockwise direction. Okay? Divided by delta t or time, it takes 365.25 day, convert to hour, convert to minute, finally convert to second. So its value is equal to 1.99 times 10 power negative 7 rad per second. So you can find out the value of the angular speed of orbiting Earth or moving Earth around the sun without giving any value. Okay, so also you can solve this question, and also this question is very important. Okay, now I'm going to solve this question. Earth has an equatorial radius of approximately 6,380 kilometers and it rotates 360 degrees every 24 hours. Theta was given is equal to 360 degrees. Okay, so the time also was given 24 hours. Okay, what is the angular displacement of the person standing on the equator for 3 hours? Theta 2 is unknown and delta t is equal to 3 hours. As I mentioned before, if you see two time or two angular displacement, you have to think about this equation. Theta 1 over theta 2 theta 2 over t2 is equal to theta 1 over t1. Okay, so you can replace to find the theta 1 or theta 2 is equal to 45 degrees. A bicyclist rides along a circular track if the bicycles travel around exactly half of the track. What do you mean by half of the track? This is complete track, but this is half of track. Okay, what is this? This is half of the track. Okay, for half of the track, how many revolutions do we have? 1.2 rev, which is equal to 180 degrees and is equal to pi rad. So in this question, the angular displacement is given indirectly. Okay, so is equal to half rev, convert to rad, multiply by 2 pi. You can find out the angular speed. Okay, in the case when the bicyclist rides along a circle, if the bicyclist travels around exactly 3/4 of the track, it means that 3/4. 3/4, it means that here, okay? This is 3/4. 3/4 revolution, okay? So that's all for today. Hope you benefited from my lesson. And thank you for listening.